Welcome to IBLE Math, where we teach IB Math for students, by students. In today's video, we will see the basics. We'll go over the basics of geometric sequences. Now, in previous videos, we saw what arithmetic sequences were, and we did some basic exercises and some more advanced exercises. And today we'll do the same, but with geometric sequences. Now, what are geometric sequences? A geometric sequence is a type of sequence. So if before we had arithmetic sequences, which consisted of numbers that had always a common difference between each other, a geometric sequence has always a common ratio. What do I mean by that? Well, instead of summing a certain number to get the next term, such as, for instance, having 1, then having 3, 5, 7. So here we are adding 2 each time, right? Instead of doing this, a geometric sequence multiplies a certain value every time. And so for this first example, for instance, we see how from 1 to 2, from 2 to 4, from 4 to 8, and from 8 to 16, the values are always times by 2. Now, this is the only difference there is between geometric and arithmetic sequences. One of them is adding, the other one is multiplying. Okay, so the general equation for a geometric sequence is this one here, and it states mainly that the nth term, you might already be familiar with this from our previous video on arithmetic sequences, the nth term, so a specific term term in our sequence, so might be the third term, the fourth term, the fifth term, the 11th term, will be equal to a, which is again our first term in the sequence. So remember, this can also be written as u1. Okay, so our first term in the sequence, times the common ratio, which is written as an r, to the power of the number of terms there are. So sorry, the number of terms or the position of the term we're looking for minus 1. So in case we're looking for u8, the 8th term, we would need to do all these things times ratio to the power of 8 minus 1, which would be 7. Only this, okay? So we'll see now how this works more in detail. Now we'll go to our first exercise. It says they give us a sequence, a geometric sequence, where we have already identified before that there's always multiplication by 2. So 1, 2, 4, 8, 16. And they tell us, what would the 7th term be? Well, the 7th term is u7. So that will be equal to a, which is our first number in the sequence, which is 1. So it's going to be 1 times, which is like timesing by nothing. 1 times r. So our common ratio will be equal to 2. We've already seen this in here. We've seen this here. Times 2 to the power of 7 minus 1. 7 minus 1. Because we know that our term, the term we're looking for, is the 7th term, so it's in the 7th position. But we have to subtract 1 as the formula indicates. Okay, so now we can calculate what the 7th term would be. So our 7th term will be 1 times 2 to the power of 6, which is equal to 64. And that's our 7th term. Quite easy, at least this first exercise. Now, exercise 2 says the first term of a geometric sequence is 3. So we'll say a equals 3. Remember that a is the same as u1, so we can write it like this. And the common ratio is 1/3, so r equals 1/3. Determine which term has the value of 1/81. Well, our unknown term will be 1 over 81, and we have to calculate what n is. So what is the position of the term? Now this is a specific term, and if we again look at the formula, this 1 over 81 will be un, will be a certain, a specific value, a specific number in our sequence, in our geometric sequence. So that would be 1 over 81 equals a, which is 3, times r, which is 1/3, to the power of n minus 1. And n minus 1 will remain like this. So we know that 1 over 81 will be equal to, 1 over 81 over 3 will be equal to 1/3 to the power of n minus 1. We are simply isolating all this because that's, you'll see now what we'll do. So usually you want to do this. I'm continuing here. So 1 over 243 equals 1/3 to n minus 1. Now here we have to use logarithms. Now if you're not familiar with them, log base a of b, if we say that this equals c, we are mainly saying that a to the power of c equals b. And so if we keep this in mind, I'm just going to delete this. We can write a logarithm with this, so we can say log base 1/3 of 1 over 243 equals n minus 1. And we have to use a calculator here. So I'm just gonna write it. So log, here again, you should use a calculator because doing this by hand is almost impossible. So you should write log base 1/3 of 1 over 243, and this will equal 5. So 5 equals n minus 1, n equals 6. And that's it. In case you have some problems with logarithms, just let us know in the comments and we will make sure, for sure make a video on this topic. So n equals 6, and this is our term. So we could say it's u6. This is the term that has a value of 1 over 81. This is what we just calculated. So exercise 2 is done. Exercise 3 says, find the common ratio of each of the following sequences. Well, remember, the common ratio is always the jump, the race between here. I write it as r, so that's the common ratio. Well, we know that what we could do always to find the common ratio is to take any number. So this is our first, second, and third term. So we take any term, let's take 12, and we divide it by the number they have before, the previous number. So that would be 3, which we could also use obviously 48 over 12. It's just taking one value and then dividing it by the number before. And so we will calculate the ratio between these two numbers, which is the common ratio, and you will see how this is equal to 4 and this is also equal to 4. And so these two results, this will equal our ratio, our common ratio. Both of these values. Now, there's also, for our second exercise, it's slightly different because you see how we will have to divide 4 over 8. So it won't give us an integer. Again, we're taking one number and dividing it by the one before. we're not dividing it by a smaller number. We're not taking 4 and then dividing it by 2. We're just taking the number before. So yes, this won't give us an integer. This will give us actually 1/2. So the common ratio is 1/2. If we multiply 8 times 1/2, we will get 4. And if we multiply 4 times 1/2, we will get 2. Sorry for that. Yeah, so that's it. And so this will be equal to our common ratio. We can write it like this. I'll also indicate that this is our final result. And now our third sequence. Well, what's the jump between this? What's the ratio? What are we multiplying each value by to get the next value? Well, really what we're doing, we can obviously calculate it like this. So it would be 5/5. We're taking this value and dividing it by the previous one. And see how this is 1, which is our common ratio. Now, the common ratio can obviously also be equal to 1. And this means that there's simply no jump, no change in the numbers. Each number is multiplied by 1, and it will give, therefore, the same number. So 5 times 1 will be 5, times 1 will be 5. And this is how we're doing it. So we're multiplying each of these values by 1. And so we found the common ratios of these 3 sequences, geometric sequences. Now, exercise 4 is also quite interesting, because what they are asking us to do, well, they are asking us to find the first term. What is the first term? And before they give us a brief explanation, so they say that the fourth term of a geometric sequence, so U4 equals 625, and the common ratio is 5, so R equals 5. Now, remember the formula, UN equals A times R to the n minus 1, A can again be also written as U1, and really, the only thing we have to do is to substitute the values in here. So we know that 625 equals A times the ratio, which they tell us is 5. They say this in here, so we know it's 5, to the power of n minus 1. Now, what's n? Well, they gave us our fourth term, so we know that n is 4, but then it's minus 1. And so A equals, 625. Sorry for that. Ooh, I don't know what just happened. 625 equals A times 5 to the power of 3. And so A equals, now again, there's just rearranging just a bit, which equals 625 over 125, which is equal to 5. And so note how our first term in the sequence, in the geometric sequence, will be equal to 5, which is also our common ratio. So these kind of things can sometimes happen, obviously. And now last, our exercise 5 says the following. The sixth term of a geometric sequence is 64, and the first term is 2. What is the common ratio? It should say, what is the common ratio? Well, we know that U6 equals 64, and we know that our first term, A, equals 2. So let me just write it like this. So what is the common ratio? R. What is it? And we also know, by the way, that n equals 6, because we can deduce this from here. If they tell us it's the sixth term, we know that n will be equal to 6. So again, we'll just write the formula. 64, we'll substitute the values into the equation. So 64 equals 2, because that's our first value, times R, which we don't know, to the power of 6 minus 1. Right? And so we know that so we know that 64 will be equal to 2 times r to the power of 5. And so we get 32 equals r to the power of 5, and r will be equal to the 5th root of, 32. Again, this is some basic algebra. And now if you write this into the calculator, you'll see how we get that r equals 2. And so we calculated our common ratio, and we've finished the video. These were 5 very easy, or not easy, but interesting examples. We'll see perhaps some more complicated examples in a future video. If you like the video, don't forget to give it a like, subscribe to our channel, and stay tuned for future content. We'll be uploading approximately 4 videos per week on the IB Math syllabus. Remember, just as a reminder, our channel is an open channel. In case you have any interesting video that you've made your own and that could serve as a good explanation for any topic, please send it to the email that we will give in our description, in the description of the video. We will simply check it, review it, and see that it's appropriate enough, and we'll post it in this channel with your credits. Again, thanks for watching, and see you in a future video.